The most powerful telescope ever built was launched into space on Christmas Day, 2021. Its mission was simple: look back, further than any human had ever looked, to the moments after the universe was born. For 3 years, the James Webb Space Telescope has been sending its findings home, and those findings have created a problem. Because the James Webb Space Telescope has detected something that, according to everything we thought we knew about the cosmos, should not exist. Galaxies that are too old, stars that formed too quickly, structures that, by every model in modern cosmology, simply could not have been there. The light from these galaxies has been traveling for over 13 billion years to reach us, which means we are seeing them as they were, in the moments after the Big Bang itself. And what they appear to show is that the Big Bang may not have been the beginning. There may have been something before it, and the James Webb Space Telescope may have just found it. Tonight, we go further back than time itself. You're watching Cosmic Unknown, where verified science meets the questions science cannot yet answer. Subscribe before we begin, because by the end of this video, you may not look at the night sky the same way again. To understand why this matters, you have to understand what the James Webb Space Telescope actually is. It is the most ambitious scientific instrument ever launched by human civilization. $10 billion, 3 decades of development, thousands of engineers across a dozen nations, a folded mirror the size of a tennis court that had to unfold itself perfectly in the cold of deep space, without a single human hand to fix it if it failed. It sits over 1 million miles from Earth, 4 times the distance to the Moon, in a region of space called the second Lagrange point, a place where the gravity of the Sun and the gravity of the Earth balance so precisely that the telescope can hover there, motionless, for decades. Its purpose is to do what no telescope before it has ever managed: to see the past. Because of the speed of light, when we look at distant objects in space, we are not seeing them as they are now. We are seeing them as they were when the light left them. Look at the Sun, and you are seeing it as it was 8 minutes ago. Look at the nearest star, and you are seeing it as it was 4 years ago. Look at the most distant galaxy visible to the human eye, and you are seeing it as it was almost 3 million years ago. The James Webb Space Telescope was designed to look much, much further than that. It was designed to look back to the beginning of everything, to the era cosmologists call the Cosmic Dawn, the moment when the first stars in the universe began to ignite, when the first matter began to cool, when the first structures in the cosmos started to form. When James Webb began collecting data in the summer of 2022, scientists believed they knew what it would find. They had the model, they had the math, they had decades of observations from older telescopes, Hubble, Spitzer, Herschel, that all agreed on the same picture. In the first few 100 million years after the Big Bang, the universe should have been simple, scattered, empty, a faint, cold, dark place, hydrogen gas drifting in vast, invisible clouds. Slowly, gradually, those clouds would collapse under their own gravity. And only after 1 billion years or more would the first true galaxies, small, faint, immature, begin to form. That was the prediction. That was the model. That was what every astronomer alive expected James Webb to confirm. Then James Webb opened its eye, and what it saw broke everything. The first deep field images were released to the public on July 11th, 2022. The world saw a small patch of sky, no bigger than a grain of sand held at arm's length. And inside that grain of sand were thousands of galaxies, some closer, some further, some pulled and stretched into ribbons by the gravity of others. It was beautiful. It was unprecedented. The public was awestruck. But the scientists looking at the data were quiet, because something in those images was wrong. The galaxies that should have been the youngest, the most distant, The ones whose light had traveled the longest to reach us were not faint. They were not small. They were not the immature, just-forming structures the model had predicted. They were enormous, mature, bright, already containing hundreds of billions of stars, already shining with the light of fully developed galaxies, less than 500 million years after the universe began. The first one they confirmed was named JWST 13-0, a galaxy whose light had been traveling toward us for 13.4 billion years. Then came JWST 14-0. Even further back, even more massive, even more impossible. Then put dozens more, galaxies that had no business existing, galaxies that could not, by any known law of physics, have grown that big, that fast, that close to the beginning. Astronomers began calling them universe breakers. And the more James Webb looked, the more of them it found. These were not isolated outliers. They were not measurement errors. They were a pattern so persistent that within 2 years of the telescope's launch, papers began appearing in academic journals describing what was being called the JWST tension, a polite scientific phrase for what was actually happening. Modern cosmology was breaking. Adam Frank, an astrophysicist at the University of Rochester, described the situation in a single sentence that has been quoted again and again since. He said it was like finding a 50-year-old man in a kindergarten class. These galaxies were not supposed to be there, but they were. And no one could yet explain why. To grasp the weight of what James Webb had uncovered, you have to understand what we thought happened in the beginning. The Big Bang Theory describes a universe that began 13.8 billion years ago, in a state of unimaginable density and heat. In the first fraction of a second, the universe expanded faster than the speed of light, in a process called cosmic inflation. In the next minutes, the basic building blocks of matter, hydrogen and helium nuclei, formed in the cooling soup. For the next 380,000 years, the universe was opaque. A dense, glowing fog of plasma so hot that light could not travel freely through it. Then came an event called recombination. The universe cooled enough for electrons and nuclei to bind together into the first true atoms. The fog cleared. Light, for the first time, was free to move. The light that escaped in that moment is still traveling today. We can detect it everywhere we point our instruments. We call it the cosmic microwave background, the baby photo of the universe. After recombination came a long, cold, dark age. For perhaps 100 million years, the universe was simply expanding hydrogen gas. No stars, no galaxies, no light, just darkness and the slow, patient pull of gravity, drawing matter together over millions of years. Then, gradually, the first stars ignited. And then, much later, perhaps 500 million to 1 billion years after the beginning, the first small, faint, immature galaxies should have begun to form. That was the model that had survived almost a century of testing, the model that explained the cosmic microwave background, the model that explained the abundance of light elements, the model that explained the large-scale structure of the cosmos. It was, by every measure, one of the most successful theories in the history of science. And the galaxies James Webb has found do not fit it. Not by a little, by a factor of 5, by a factor of 10. In some cases, by a factor of 100. When new data contradicts an established theory, scientists do not simply throw the theory away. First, they look for explanations within the existing framework. So they checked. Was the data wrong? No. The same galaxies were observed by multiple instruments, multiple times. Were the distance measurements wrong? Spectroscopy confirmed the redshifts. The galaxies were as far away and therefore as ancient as the data suggested. Was the brightness an illusion? Could dust have made these galaxies appear larger than they really are? After exhaustive modeling, the answer was no. The galaxies were not just bright, they were massive. Their stars were old, their structure was developed. Was there gravitational lensing, a foreground galaxy magnifying the light? In a few cases, yes. In most cases, no. One by one, every easy explanation was ruled out, which left only the harder ones. The first possibility, the standard model of cosmology, the one called lambda cold dark matter, has a hidden flaw. Perhaps dark matter does not behave the way we think it does. Perhaps the early universe formed structures faster than the model predicts because some property of dark matter accelerated the collapse of gas clouds. This would be uncomfortable, but survivable. The second possibility, the Big Bang itself, happened differently than we thought. Perhaps cosmic inflation, that sudden expansion in the first fraction of a second, was longer or stronger or shaped reality in ways the current models cannot capture. Perhaps the first stars were not made of just hydrogen and helium. Perhaps they were primordial black holes that seeded galaxy formation almost from the beginning. This would be more uncomfortable. It would require rewriting parts of physics that have stood for decades. But there is a third possibility, a possibility most working astronomers do not like to discuss in public. A possibility that, if it turns out to be true, would shake the foundations of every cosmological model ever built. The third possibility is this: maybe the Big Bang was not the beginning. Maybe what James Webb is detecting are the remnants of structures that existed before our universe ever began. The idea sounds, on first hearing, like science fiction, but it is not. It is a serious scientific hypothesis, defended by some of the most respected physicists alive. The most famous of them is Sir Roger Penrose, a Nobel Prize winner, a mathematician who collaborated with Stephen Hawking on the geometry of black holes, one of the most accomplished minds in 20th century physics. Penrose has spent decades developing a theory called Conformal Cyclic cosmology. In Penrose's model, our universe is not the first universe. It is one in an infinite chain of universes, each one beginning with its own Big Bang, expanding for trillions of years, and eventually fading into a cold, empty, eternal darkness. But Penrose argues that the darkness is not truly the end. When the last black holes evaporate, when the last stars burn out, when matter itself decays away, the universe enters a state where nothing distinguishes one moment from another. No clocks, no reference frames, no structure of any kind. And in that state, Penrose argues, the universe resets. The infinite cold becomes mathematically equivalent to a new singularity, a new beginning, a new Big Bang. Each universe ends, and the next one begins. Each cycle Penrose calls an eon. And here is the part of the theory that is most difficult to accept. Penrose argues that small remnants of the previous aeon, patterns, structures, echoes, can survive into the next. He has spent the last decade looking for these echoes in the cosmic microwave background, and he claims to have found them, concentric rings of low temperature, anomalous patterns, what he calls Hawking points, the imprints of supermassive black holes that evaporated in the previous universe, leaving their signature burned into the fabric of ours. For most of his career, this hypothesis was dismissed by the mainstream. Speculative, unfalsifiable, the eccentric obsession of a brilliant but aging physicist. But then James Webb came online, and the universe began producing structures that the standard model said should not exist. And suddenly, Penrose's theory did not seem so eccentric anymore. Conformal cyclic cosmology is not the only theory of this kind. There is the Big Bounce, a model in which our universe was born not from a singularity, but from the collapse of a previous one. A universe that contracted to almost nothing, and then rebounded outward, becoming the expanding cosmos we live in today. There is eternal inflation, a theory in which the moment of cosmic inflation, that fraction of a second of impossible expansion, never truly ended. It is still happening, somewhere out beyond the horizon of what we can see. New universes are constantly being born, like bubbles in an infinite cosmic foam. Our universe is just one of them. Older bubbles may have existed for far, far longer than ours. There is the string theory landscape, a model in which our universe is one of perhaps 10 to the 500th power possible universes, each with different physical laws, all coexisting in a higher dimensional reality. In each of these theories, and in others, the implication is the same. The Big Bang was not the beginning of existence. It was simply the beginning of our universe. And if James Webb is detecting structures that formed unreasonably fast in the early cosmos, perhaps the explanation is that they did not form from nothing. Perhaps they were already there, seeds carried over from a previous reality, atoms that survived the death of a previous universe, structures imprinted on the fabric of space-time before our cosmos was ever born. If that is true, then every star you have ever seen contains particles older than time itself. The carbon in your bones, the iron in your blood, the water in your eyes. Some of those atoms may have been forged not in the death of distant stars in our universe, but in the death of stars in another one, a universe that ended so that ours could begin. There is a deeper question buried beneath all of this. If our universe is not the first, if it is one of many, or one of infinite, then what does that say about everything we thought we knew? What does it mean for the laws of physics, if those laws may be different in other universes? What does it mean for the meaning of time, if time itself only exists within each individual cosmos? What does it mean for the question of why anything exists at all, if existence is not a singular event, but an eternal process, endlessly repeating, endlessly recurring, with no beginning we can ever truly find? These are not questions astronomers were trained to answer. They are not questions science is yet equipped to answer. But they are the questions James Webb's data is forcing us to ask. Whatever the explanation turns out to be, whether the standard model needs minor adjustment, whether new physics is required, or whether something genuinely existed before the Big Bang, one thing is now certain. Our picture of the cosmos was incomplete. The universe is older, stranger, more layered than we thought. And the James Webb Space Telescope is showing us, image by image, that the walls of reality are further away than we ever imagined. There is a temptation, when faced with discoveries of this scale, to dismiss them, to say that the model will be patched, that the data will be reinterpreted, that science always finds an explanation in the end. And perhaps it will. But there is another possibility worth sitting with. There is the possibility that the universe is genuinely far older and far more mysterious than the comfortable timeline of 13.8 billion years. There is the possibility that the Big Bang was a beginning, but not the beginning. There is the possibility that beyond the edge of what our most powerful telescope can see, there are more eons, more cosmoses, more expansions and contractions, more births and deaths of reality, more histories than any single mind could ever comprehend. And there is the possibility that for the first time in human history, we have built an instrument capable of catching their faint, ancient, dying echoes. We thought we were almost there. We thought we had reached the edge of the past. We were wrong. The past goes much further back than we knew, perhaps infinitely. And from now on, every time you look up at the night sky, you will be looking not at the universe. You will be looking at the latest one. This was Cosmic Unknown. If this video took you somewhere new, subscribe, because the more James Webb sees, the more we realize how little we ever truly understood. In the next video, we go further, to what may lie beyond the edge of the observable universe itself. Until then, sleep tonight knowing the cosmos is older than time, and we are only just beginning to listen.